Good afternoon. Thank you for having us today. My name is Joe Blasey with HNTB, and I have Zach Harland and Sohail Sajadi here with me too. And we're going to talk with you about a project that we've been working on where we used different PTV tools, Vistro, Vizoom, and Visim to model a light rail project. So we call it multi-resolution modeling of a light rail system. Okay, so I'll get started and walk through some of the background of the project. And then Zach is going to talk about our model development process, and Sohail will pick that up as well. And then we'll finish up with some lessons learned and some suggestions, one of which PTV is already taken care of. So look at that responsiveness. Right. Okay. So this project area, it's mostly on one corridor, but there is a little bend in it, as you can see up at the north end there. 5.6 miles of urban arterial corridor with a total of 35 signalized intersections. They're owned by different entities, so 24 of them were city-owned, 11 of them are state-owned. We modeled 9 different unsignalized intersections, but as you might expect, there were many more unsignalized intersections along the corridor that we did not model. We just tried to pick the most important ones. And there is one roundabout, which was interesting because we had to figure out how we were going to get a light rail vehicle through a roundabout. And these guys will talk about that a little bit more later. And then we have 2 freeway interchanges. So one of them you can see pretty obvious, kind of in the middle there. For that one, we did model some of the freeway because we knew that today that ramp terminal backs up onto the freeway. And so we wanted to be able to capture the effects of that. For the other freeway, it's a little bit to the south of that. The people close might be able to see the diamond ramps there. But we did not model that freeway because we were not really concerned about that backing up, and we're trying to keep this as simple as we could. So this is a proposed light rail corridor connecting the southern part of the city, Midtown, and then an area called Downtown West. And there's a lot of growth that's already happening in the corridor, and then a lot of hopeful growth in the corridor that this transit project was hoping to spur. So job centers, healthcare, education, neighborhoods, and then it interacts with other transit networks as well. Some of the bus lines. There's also another rail corridor that it interacts with as well. So in putting the light rail down this corridor, the impacts to traffic, the main impact is really a reduction in lanes. So a lot of this corridor is at least 4 lanes wide today, some areas 6. And so in general, we're taking a lane and giving it to light rail traffic. So we needed to look at the impacts of that to general traffic. There's also some pedestrians along the corridor, not too many, but we know that by adding the light rail, we're going to be generating more pedestrian traffic. The light rail is also proposed to go down the middle of the road in the median. And so anyone who needs to access the light rail is going to need to cross the street either halfway across or all the way across. So we wanted to make sure we could capture the impacts to pedestrians. The corridor has up to 31,000 daily traffic on it in 2024, and modest growth puts that at about 35,000 by 2050, and that's the most crowded part of the corridor. There are other parts that are way lower than that. We were modeling a mix of existing traffic and bus routes, as I mentioned, and then almost all of our signals we're proposing TSP. We don't believe we're going to get authorization to do it at all of them, especially at the freeway ramps, because there is such a concern about backing onto the freeway. But we're pushing to get TSP at most of the intersections, and then preemption is how we're handling that roundabout, which we'll talk about later. So I've already kind of talked about a lot of this. We want to model the interaction between our existing modes, bus routes, and the light rail. We want to test some different geometric alternatives in different locations. We want to analyze the impacts of TSP and preemption, both to the general traffic traveling public, but also what are the benefits to the light rail vehicle, and maybe even to buses along the corridor. Determine the impact on operations, and then in the end, also provide a visualization that we can show to higher level decision makers and ultimately the public. And we will have a short video to show you later as well. Now I'll pass it off to Zach to talk about our process.
Thank you, Joe. So an existing synchro network was provided by the client with partial geometry developed, but this was kind of an older, outdated model, so we needed to further develop it and also make some changes for the current geometry. So we brought that into synchro, and then we developed that, and then Myovision took counts for a 2-day period and collected raw counts for us to use to determine the peak hours, which were determined as 7:30 to 8:30 a.m. and 4 to 5 p.m. And we also, to supplement Myovision's counts, we also conducted observations, and we also did travel times in person to make sure everything was kind of copacetic with what they were seeing out there as well. And then the signal timings were provided, like Joe said, we had 24 that were provided by the city, and then 11 that were provided by the state entity. And then the information from Synchro, Myovision, and then the signal timings was incorporated into the Bistro model. And then, like I said, we developed the rest of the geometry in Bistro, and then did the volume balancing and everything in there, and then took that to Bazoom to develop our OD pairs, and use the T-flow fuzzy to solve the matrices and everything so that we could take it to BSIM and develop all of our static routings and OD pairs in BSIM. And then along with that, we also use NPM RDS Redis to have travel times to compare with what we were seeing in the field and what we were trying to calibrate our model to. So for the Bistro analysis, as mentioned, the network was partially developed in Synchro, and then we finalized the network in Bistro, and then using the traffic counts that were collected, we determined the peak hour from 7:30 to 8:30 a.m. and 4 to 5 p.m. And then we found the most consistent peak hour between the AM and PM and applied that to the Bistro model. And then we did the volume balancing and inputting. We also created source sinks in the model to balance it more easily. And this also helped later on for when we were adding the light rail to the system, because we could dump some of those volumes off into these source sinks. And also there was a difference in growth rates across the network for the future. So some were higher than others. So it's hard to balance between the existing intersections. So we also incorporated source sinks for that reason as well. And then we did all of our signal optimization and cycle time optimization in Bistro. And then we coordinated the signals for the build as well on one network. So it was easier for when we did the BISA model to apply the light rail and have TSP and preemption included in there as well. And then from Vistra, as I said, we brought the balance volumes in and exported those to Vazoom to create the OD pairs. And then we developed a T-flow fuzzy with the procedure sequence feature in Vazoom. And then we use that T-flow fuzzy to create our OD matrices and solve our OD pairs. And then we brought it into our own Excel sheet once it was solved and brought into the Vista model. We brought it into our own Excel sheet later on so that we could, with those sourcings that we had and everything, some of the origin and destination pairs were different. So we used our own Excel sheet that we created to kind of solve and zero out everything so that if there was extra destinations or origins, we kind of have this formula that we use to determine where those were being seen, and we could kind of pull that out of the Vissim static routes and put it into our Excel sheet and then fix everything and add those in, put it back in, and then match the relative flows up. So the routes were imported into Vissim from Vazoom for the existing, and we had to make some manual adjustments to the route pass in some cases because it wasn't being brought into the correct link in all the cases. And we had to manually adjust those, but with kind of the feature now where you can modify multiple routes at one time, that made it a lot easier. Um, and then the NPM RDS travel time was used to check the calibration of the Vista model and confirm the travel times within a certain percentage of the field travel times, and then make sure that the field traffic counts were set up correctly. And as shown in the photo to the right, based on some of the access points that were changing in the build alternative, we created what we call like dummy links, and we basically just put these links onto other destinations in the network that would basically connect to them, and then they would reroute to an existing destination so that the vehicles would not be directly going to those, because we had a lot of areas where there was turns being cut off, all the unsignalized intersections. We eliminated turns, and at all the signalized intersections, it was protected turns only. So we had to kind of reroute a lot of those vehicles at the unsignalized areas, and it was just easier as far as the Vazoom model goes too. So we didn't have to completely revamp all our OD pairs and everything. And we just used our relative flows and we shifted all the routes for where those were going to kind of mimic that. And then we didn't have to deal with adjusting and changing all these volumes and everything else. So that was kind of the workaround we used there. And then we also applied the existing bus routes in line to the corridor to kind of test the operations with alternative modes of transportation in the network. But because of the incorporation of the light rail, many of the bus routes and lines within the corridor were removed in the build alternative and shifted to being only temporarily within the network. So only for like minimal time as opposed to before. And then we also had pedestrian crossings here that were added to the signal controllers as well. But a lot of these areas didn't have high pedestrian crossings, so that wasn't too common of a barrier to deal with. But we did apply those to the RBC files as well during the AM and the PM peak hours. So that was kind of our modeling process that we use and kind of transitioning from the one software to another. And so Hal's going to talk about the TSP and preemption we used, and then the challenges and recommendations we had.
All right. Thank you, Zach. The fun part, the transit signal priority and preemption. We model transit signal priority in almost every location. As Joe mentioned, in every signal as intersection, we try to have transit signal priority. We had also we had a preemption at the roundabout. As you saw, it was on the top right corner of our network. This is looks like more of a European application when you can see the light rail in the middle of the roundabout. You don't see it much here in North America, but this is something that we worked on. And the transit signal, the difference between preemption and transit signal priority is that transit signal priority is optional. So the signal controller will think if it can allow an advance in progression to the movement that is benefiting from transit signal priority. Where in preemption, we are sure that we get red light for all the movement that are enabled with preemption. And that was we had some challenges regarding application of the transit signal priority and preemption, which I'm going to talk about in a different slide. This is the animation of the light rail approaching the roundabout. As you can see, the lights are green at the moment, but all of them will become red as the light rail approaches the roundabout. And then once the light rail passes the roundabout, it will send a signal to the signal controller that, hey, you can turn the lights of the other movements to green. And this is how preemption works. Challenges and recommendation. We had ongoing construction in the project, like many other projects that are ongoing construction. The volume is changing, and so we need to go back and change our volumes. Lack of NP MRDS data, similar to many data sources. There was times and days that we didn't have any data from NPR, and we had to take account for that somehow. And also NPMRDS data lacks segments, so we also needed to we need to also face this challenge. Walk and flash don't walk time. There was a limitation in the RBC controller. I think it has been taken care of. It was one of the challenges that we faced, and thank you for PTV Group for fixing this. We had to, before that, we had to limit the green time of the parallel movement to the pedestrian movement to the flashing flash don't walk time and walk time one time in total. So that was been taken care of. Well, one of the challenges that we have, preemption example, we had to use it from another project that we previously worked, so we couldn't find a good example from vSIM installation that comes with a standard vSIM installation for preemption. I would this is something maybe for tomorrow to suggest to have more example files for preemption. The other two bullet points are almost the same, referring to the same issue, but they're in different tools. So changes to signal after VSTRO optimization. Once we optimize the VSTRO file, in order to be able to apply it in vSIM, we had to adjust it manually in vSIM. Another challenge was that VSTRO doesn't, because of the methodology, it's not a software issue. Is another limitation of the software, is a limitation of the methodology, actually, that it doesn't accommodate transit signal priority nor preemption in the methodology. So we had to take one, and if you think about it, VSTRO is more of a macroscopic level analysis. vSIM is microscopic, so the microscopic simulation is more granular compared to macroscopic modeling. So we have the opportunity to apply TSP and preemption in vSIM, but not in VSTRO because of the limitation of the methodology behind VSTRO. So we had to adjust manually for application in vSIM. And with that, I think we are ready to take questions.